Okay, so we have our second problem here. Remember the same concept. We want to read, underline, highlight any important information to help us answer those questions to form our constraints or our inequalities. So the area of a parking lot is 600 square meters. We know we have a parking lot that's 600 square meters. A car requires 6 square meters. A bus requires 30 square meters. So when you park them, a car needs 6 square meters to park. A bus needs 30 square meters. And we're in a parking lot that fits 600 square meters. The attendant can handle 60 vehicles, and if we look at if a vehicle is charged 250, so we have a car that's charged 250 and a bus that's charged 750. So when they go in, they get charged 250. How many of each should be accepted to maximize income? How many of each should be accepted to maximize income? So what's the problem? If we want to summarize the problem, what does it talk about? It's talking about parking for cars and buses. Right, some kind of parking garage, trying to park in there. What is the question? We have, again, two types of questions here. We want to know how many of each, so how many cars, how many buses, and then we want to try to maximize the income. So how many of each, and we want to try to maximize income. Again, your Team B will be looking at how to actually maximize that income that we're trying to make off those cars and buses. Identify the variables. What are unknowns? What don't we know? Well, we got cars going in, right? We know they fit 6 square meters. We know buses fit 30 square meters. We don't know how many have gone into the parking lot or how many should be accepted to be able to maximize the income. So those are going to be our variables. Those are going to be our unknowns. So X is going to be our cars, the amount of cars, and Y is going to be the amount of buses. Now we want to model the situations with the inequalities. So we know that you have cars going in. We know we have buses going in. So what are constraints here? What are some limits that we have? Well, we know that the area of the parking lot is 600 square meters, right? So we know that when cars go in, one car is going to go in, it's going to fit 6 square meters. A bus is going to go in, it's going to fit 30 square meters. We don't know how many cars and buses are going in, but we know we can fit them all in until we reach 600 square meters. Now, can I go over 600 square meters? No, because that only allows 600 square meters. It's the only way that they could fit, but it could be less than that, right? So we want to look at less than or equal to 600. But where am I getting that from? I'm getting it from the car that takes 6 square meters, and I'm getting it from the buses that take 30 square meters. So that gives me my first constraint. 6x plus 30y is less than or equal to 600. The second constraint is what they tell me about the attendant. The attendant can only handle 60 vehicles. So get all the cars in you want, get all the buses in that you want, but I can only handle 60 vehicles. So I'm going to end up with less than or equal to 60 because I can only handle 60. Bring me all the cars you got, bring me all the buses you got, but I'm only going to bring in 60 vehicles. So I want to be able to get those into our grid. Now, if you remember, we're only going to be working with our first quadrant here. Now, why is that? What's the reason behind it? And we went over it in class. That's because we want the amount of cars to be greater than or equal to 0 and the amount of buses to be greater than or equal to 0. We can't have any negative buses. We can't have any negative cars. That doesn't make sense. We can have 0 cars or we can have 0 buses, but not negative. That's why we're going to be working within this first quadrant over here. So basically, this whole area is shaded because we're looking at x is greater than or equal to 0, y is greater than or equal to 0. And as you can tell, it's already shaded for you. Next, we want to take our standard form inequalities, get them into some kind of x and y intercepts to be able to easily get those onto our grid. So again, plug in 0 in for y, you're left with 6x is less than or equal to 600. Divide by 6 on both sides, x is going to be equal to 100. That's going to be my first point for that inequality. Now if I plug in 0 in for x, I'm left with 30y is less than or equal to 600. Divide by 30 on both sides, that's going to give me 20. Brain fart much? Maybe. So that's going to give me y is less than or equal to 20. Next, we have x plus y is less than or equal to 600. Again, plug in 0 and for y, you're going to be left with x is less than or equal to 60. Plug in 0 and for x, you're left with y is less than or equal to 60. Now that I have my points for my inequalities, I can go ahead and put those onto our grid. Now if you notice, I have to go all the way up to 100. Now that's a lot. So if I take a look at here, I can't go up by ones. I don't want to go up by tens. That's too much. I think fives would actually work out best here. So if I was to go up by fives, they'll leave me with 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, and 100 right over here. Because one of our points has 100. So we're looking at 100, and then the other point is 20. So 5, 10, 15, 20. That's going to be our first inequality. We can go ahead and draw that line. And we're looking at y is less than or equal to 20. So we're looking at this shaded area right over here. Next, we're going to grab our x is less than or equal to 60, so x equals 60, and y is less than or equal to 60. So x equals 60 is going to be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. And y is equal to 60, so we're going to go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. And our inequality is going to connect from my x-intercept to my y-intercept. And we're going to be looking at less than. So we're looking at y is less than or equal to 60. So here's y. I want less than or equal to 60, so I want this whole region over here. Now if you'll notice, I have my feasible region. And my feasible region is wherever I'm shadowing, and wherever I'm highlighting over my other region. So that's really going to be working within this feasible region right over here. So this right here is going to be my feasible region, not this, and not this. Please make sure you have this on your graphs, and then your team B will let you know, what do I do with this feasible region? How do I create this income function? And how do I go and evaluate everything else after that? All right, see y'all later.